Hi and welcome back. In the previous episode, we talked about the 5 main elements of programming, in general, regardless of the programming language. Does anybody remember what they are? Right, it's data, operators, functions, branching, and loops. And in this episode, we're going to talk about some of those, so let's get right to it. Alright, so this is where we left off last time. Before we move on, let's copy the existing code, create a new file named lesson2.c, and paste the code. Alright, so we have this printf hello world, and a bunch of other stuff that we didn't touch upon last time, and we're not going to do that this time either. For now, all I want you to know is that the code you write must go in between this opening curly bracket and this return statement. In this example, this text hello world is the data, while this printf is a function that processes the data by displaying it in the console here. We'll talk about functions in more detail later, and for now, let's focus on the data. In code, data can take two forms, literals and variables. This text hello world is a literal, and to tell the computer where this literal begins and where it ends, we need to use these double quotes. Now, instead of printing hello world directly as we do it now, we can assign the text to a variable and then print the variable, like this. And if we now run the code, we'll see the same hello world text in the console, together with a warning that we're going to ignore for now. So if the result doesn't change, why change the code? Why use variables instead of literals? To answer this question, let's talk in a bit more detail about how computers process data. All computers have a chip that performs data processing. The chip is commonly called the Central Processing Unit, or the CPU. Now, normally, computers can handle more data than they can process at a given moment of time. In order to store the data that is not being processed at the moment, computers need some sort of memory, commonly known as RAM. The memory can be viewed as a grid of cells, where each cell can store data. To put or write data to a cell, as well as to retrieve the data from a cell, we need to know the number of the cell, which in case of computer memory is called memory address. Now, this is just a simplified illustration. In reality, computer memory is a bit more complex. Alright, so both literals and variables are stored in computer memory. One key difference is that in code, you cannot modify the literal since there is no means to access its memory location, which is not the case for variables. Now, since the memory address of a variable is known, you can access the memory cell associated with a variable and modify the contents of those cells. And this is pretty much why variables are called variables, because the data associated with a variable is modifiable, meaning it can vary. Now, why did I say data associated with a variable? See, while it's pretty common to describe a variable as a container that can store data, it's not exactly accurate. What stores data is the memory, not variables. Variables are used to access the data stored in the memory. Now, it's not really a big deal if you say that variables store data, as long as you know what's actually going on, that is. Anyways, next, if we want to use a variable, we need to create it first. Creating a variable is called variable declaration, and in our example, this part is variable declaration. To declare a variable, we need to specify its data type and its identifier, or simply put, name. So here we have a variable named s, whose data type is this char followed by an asterisk. Now remember, C is a statically typed language. What this means is that all variables in C must have an explicit data type, and that data type cannot change. So the data type of this variable s cannot change, while the data associated with a variable can. Next, to associate some data with a variable, we need to assign that data to the variable, which we do using this equal sign. This equal sign is the assignment operator. Yes, it's an operator, meaning it belongs to one of the 5 main elements of programming. There are of course more operators, and we will get to use them later on. Anyways, this line of code makes the computer reserve a spot in the memory for this variable s, and store this text hello world in that spot. And we can access that spot here by using the name of the variable. Please note that we must not enclose variable names in quotation marks. If we do, we will end up getting just s instead of hello world. Alright, so this is what you need to know about variables. They represent data in a computer program. Before you use a variable, you need to create or declare it. When declaring a variable, you need to specify its data type and its name or identifier. Variable identifier is used when using a variable, meaning when assigning data to a variable or accessing the data represented by a variable. There are of course other details related to variables, but for now you're good. So next, let's get back to this line of code that prints hello world. We now know that this s is a variable that represents this text. The text is a literal, literals are data, and this printf is a function that processes the data by printing it to the console here. So what is a function? Just like variables represent data, functions represent code or data processing instructions. So by using or calling this printf function, we tell the computer to execute the set of data processing instructions associated with a function. You can view a function as a complex instruction that consists of multiple simpler instructions. For example, instead of saying something like leave the house, walk to the bus stop, get in the bus, wait until you get to school, get off the bus, you can simply say go to school. In this case, go to school would be a function that consists of multiple simpler actions, such as getting on and off the bus. In programming, we quite often need to repeat the same set of instructions multiple times, so instead of copy-pasting the same code multiple times, we can sort of wrap it in a function and use or call that function, which is one of the advantages of using functions. Next, functions take arguments or parameters that you put inside the round brackets following the function's identifier. Some functions take one parameter, as you can see in this printf example. Some functions take more than one, and some functions take 0 parameters. However, even if a function takes 0 parameters, we still need round brackets. We just leave them empty. Now, in statically typed languages, function parameters have explicit data types, meaning if a function requires a number as a parameter, you cannot give or pass it some text. Alright, so we have a variable named s that represents text. Traditionally, a piece of text in programming is called a string, and a data type that represents strings in C is this one, char followed by an asterisk, which is also known as a char pointer, but more on that later. The main point here is that this char asterisk data type is used to represent strings, which is the programming equivalent of text. Now, if we need a variable that can represent, say, a number, we need to use another data type, such as int. So let's declare a new variable of the type int, and assign it, say, the number 5. Please note that variable names or identifiers must be unique, meaning we cannot name this variable s, because we already have a variable with that identifier. Next, this line of code does two things. It declares or creates a variable, and assigns data to that variable. In C, you can do these two things separately, like this. Please note that when assigning data or value to an existing variable, you must not put the data type in front of the variable identifier. You only do that when creating a new variable. Also note that this 5 must not be enclosed in quotation marks. If you do, it will be treated as text, not as a number. Now, remember, the data associated with a variable can be modified, meaning you can assign values to the same variable multiple times, like this. So what this line of code does is it replaces the old value, 5, with a new value, which is 10. And from this point onwards, the variable a represents 10, while 5 gets discarded. Now let's get back to functions and function parameters. Remember, the data type of a function parameter is predefined. Here, we pass the printf function what data type? Right, this char asterisk. And this variable a is of type? Right, int. So let's see what will happen if we pass this variable a to the printf function. Now if we run the code, we will get an error, which basically happens because int is not char asterisk. Now this is a feature of statically typed languages, and this doesn't happen in such languages as JavaScript or Python, which might be better for beginners. But again, I personally believe that this kind of stuff is exactly what all beginners must know before they move on to the aforementioned languages, since they do not eliminate data types, they just hide them for superficial simplicity. Alright, if we cannot pass an int to the printf function, how do we print numbers? For this, we're going to use the so-called parameterized or formatted strings. Remember, a string is a piece of text, and a formatted string is a string that can sort of convert non-string data to a string. So to print the value of this int variable a, we need to pass the printf function a formatted string that should look like this. And it should be separated from the variable a with a comma. And if we now run the code, we'll see the 10 in the console. What's important to note here is that what gets printed is the value of the variable a and not %d, which is how formatted strings work. Inside a formatted string, things that start with a % symbol are called string parameters, and string parameters get replaced by the data that comes right after. So in this case, %d is replaced by the value of the variable a, which is 10. And this is why we see 10 in the console. Now what string parameters do is they specify how the data that comes after the formatted string must be interpreted. This D stands for decimal number, which in turn instructs the computer to interpret the binary data associated with the variable a as a decimal number. If instead of D we type, say, S, it will interpret the data associated with the variable a as a string, which will result in an error since int cannot represent a string. However, we can tell the computer to interpret a number as an individual character by typing C after the percent symbol. And if we run the code, we won't get an error, but we won't see anything meaningful in the console either. But if we assign the variable a, say 100, and run the code, we will see the letter D. We'll talk about why this happens in more detail later on, and for now, the main idea is that data types matter, as they specify how binary data must be interpreted. Now if we switch back to %d, we will see 100 in the console. Alright, next, formatted strings can contain multiple parameters, as well as regular text. To show you what I mean, let's declare another int variable named, say, b, and assign it some number. And if we now modify the formatted string like this, and add the variable b as a third parameter, in the console we will see the values of both variables separated by a comma followed by a space. So what happens here is the first %d gets replaced by the value of the variable a. This comma space part is not a string parameter, so it remains unchanged, while the second %d gets replaced by the value of the variable b. Now again, a string is a piece of text that consists of individual characters. A formatted string is a string that can be built from multiple pieces, such as numbers. And if you want to use the printf function to print non-string data, you need to use formatted strings. We'll talk about formatted strings and strings in general in more detail later on, and this is pretty much it for now. But before you close this video, to test your grasp on the material covered in this lesson, you can take a quiz that you can find on our Patreon page. The link is in description. If you have questions or need help with the material in general, you can schedule a one-on-one meeting with me. The link is also in the description. And of course, don't forget to like and subscribe if you haven't yet, and turn on the bell not to miss the next video. And I'll see you then. Bye.